Hi, I'm going to talk about repetition and time. And the repetition part is not just about repeating something over time, like an animation loop, but more like a pattern. And we can see that very easily. For example, if we look into the sine and cosine that I've shown in the other video. So in Wikipedia, we have this animation, and we can see that values of rotation being fed into sine and cosine, and they look like this. So it doesn't matter how high or low you go with those values, they all conform to this oscillating pattern. So you can see this very easily. For example, here I have this array of squares, and if I use the sine function to basically here with the part move, I have the position, the world position of each square, and I'm going to feed the x-axis onto the y-axis. So in this way, I've basically managed to graph the sine function with the position of the squares. I can, of course, prop up this a little bit more and, for example, add the same sine function to z-axis and add them together. And now I have like these hills and valleys, etc. So it's kind of fun. Very cheap way to have, in this case, an oscillating pattern. If I scale the object, you can see more of that pattern, like a bigger scope of it with less resolution, etc. So let's look into other ways to basically have any value, a scalar in this case, to repeat itself. So let me hide this one, sine squares hidden, and focus on the instancer points. So if, as you probably are already used to, I use this array of instances to graph things. So basically I plug in the x value of the position of the instance into the y offset. So I get this linear graph in here. So in this case, I'm going to use the gradient, and I have two keys, one at 0, another at 1, with the according alpha values. And I'm going to use the alpha to have this transition from 0 to 1. And you notice that before and after it clamps, but I can set the behavior to repeat. So before and after those limits, it repeats the transition that was set in this range. Okay, so cheap way to get a repetition. Another way is use the curve gradient. In this case, I'm going to use the alpha because I'm dealing with scalars. And if I plug this in here, you can see that I have a graph that is set from 0 to 1. In this case, this 1 is 25 because the scalar amount is multiplied by the frames per second of my scene. My scene here is 25, so I have 25. I have to put here 25 if I want to put this on the x position in the position 1. So I have this linear transition from 0 to 1, and I have all these behaviors here that I can set that you're probably already used to from animating. So that's another way to basically get these behaviors that you are probably used to working with values in the node editor. The other one is to use a remap with a function attached, and you'll notice that when I attach the function, it automatically clamps the values. So I have here set to 0 to 1. And if I come and change the mode from constant is like equal to clamp. If I change to repeat, you see that now I have the repeating pattern, oscillating pattern, etc. So each one of these has its own advantages. So the gradient, for example, is a bit parametric because I can have the show output for the key, so I can drive the keys positions and values from outside. But it doesn't have many, repeating pattern behaviors. The curve gradient has the most behaviors, but I cannot drive the positions of the key and the values from outside, so I always have to rely on the graph editor, although it allows me to draw a very customized curve shape, unlike the others. And the remap node is with the function is probably the most parametric one because like everything can be driven from outside. So the ranges, even the curve, so I can have this, for example, I can even animate the function parameters and have this, for example, become more soft. So there are advantages in using the remap with functions. So each has its own niche. So now I'm going to talk about an operation that kind of sums up the repetition pattern, and it's called modulo, or as the name of the node is, mod. And we can see here that I just plugged the x position, and I'm using as the b value this constant node that has the value of 1. Usually modulo, when you call it up, it has 0, 0 in it. And so if I plug this in, I basically get nothing happening. So I have to type in 1, and then I have the steps with the size of 1 repeating. So it lets the graph go, and then at 1 it resets and resets and resets, etc. And modulo is basically the remainder of an operation, of a division operation. So say I have this jar with juice, and I fill cups until they're full, until I run out of juice. The last cup and the juice that remains is the remainder of this operation. So basically I'm disregarding the cups that were able to be filled up, and I just focus on the remaining juice. And this is what modulo does. Another example is that, say I have this object here. If I rotate it 30 degrees, it looks like this. So it has this apparent direction. If I rotate it 390, it looks the same. If I rotate it 750, it still looks the same. So even though there's different rotation amounts, the direction is always the same. That's because the direction that we see is the modulo of the rotation. So I have rotation 750, and if I apply modulo to it, I get the direction. And you'll notice that I can know that I already made 2 full rotations with it, 2 turns, and the turns amount is 720, and the remainder between, if I subtract 720 to 750, I get my 30 degrees. So this is basically what modulo does. Another example is that the buildings that I talked about in the integers video. So if you remember, if I have a building, apartment building, in which each apartment is like 2.4 in height, given, for example, this painting and its absolute value of 11.6, I can know that the painting is in the apartment 4. I can know that that apartment is at 9.6 meters of height, and I can know that inside that apartment, the painting is at 2 meters of height. So 3 different values just from knowing the absolute height, in this case it's the rotation, and the apartment size, which in the case of the rotation was, a cycle is 360. So here I have all the operations that were done. Like these 2 we already have seen in the integer video. So the integer division is when I divide a number and then I disregard the fractional part. And then I have the conjugation, which is basically the integer division with the multiply in the end. And then I have the modulo, which is basically this one with a subtract in the end. So this is basically, the algorithm for the modulo based on what we already seen. Okay, so here I have a compound that I've done just as a demo that basically has this, and it shows what I was talking about. So I can, with integer division, I get the floor number. And so in this case, if my apartment, let's say the apartment is 2.4, I get from 0 to 2.4, I get the value of 0. From 2.4 to 4.8, I get the value of 1. So I get the floor number 0, 1, 2, 3, etc. If I plug in the floor height, you can see that I get the height of each apartment. And if I put the wall height, I get the value of the height at every apartment. So from the floor to the ceiling, there's this transition, and then comes the next apartment, and from the floor to the ceiling, from the floor to the ceiling, etc. So it's going to look just like modulo. Okay, so I already did a compound that basically uses other types of modulos. So this modulo here uses the floor operation, but there are, if you remember from the integers video, there's floor, there's ceil, there's rounds, and there's also some form of symmetry. So here it's just like, if I plug this in here. Okay, so the floor port is just like modulo. It's the usual. Ceil will use the ceiling operation instead of floor. Then we have rounds, and you can see that things are, it was done from a centered position. And then we have symmetry. And the symmetry is basically for positive values, it shows like this, and for negative values, it shows like this. It can be useful at times when you want a symmetric approach to the problem. Okay, so this is just on the side compound that you can use for different types of flooring. Sometimes I use the round, as I used in here, to get some comparison to solve some floating point errors. But let me use modulo for something a bit more interesting than fractional values. So I'm going to take this off here, and I'm going to put up this object that has something going on. Okay, I'm not going too much into detail on how I did what I did in here, but basically what I have is I have a UV map. So I come here to Modeler. I have this object, and each square is, has the same UV in the UV space. And what I did was I deformed the UV map into this size, which is going to match the proportion of the image I'm using. So I'm using a grid of characters. So this is done using just this image. And I'm using that grid of characters to basically map in each part, which is I'm using here the part info and the index of each polygon, to map to each polygon one section of that image. So basically I have a proportion. This image is 5 by 10. That's why I have it here in these integers 5 and 10. And so I basically transform the UV map, which is here in this node. I transformed the positions of the UV map, and then I fed onto a color layer by Denis Pontonnier. So both these, the mapping nodes that we can see here, the mapping nodes and the color layer plus are from Denis. And basically here I just load in the texture image and I do nothing to it. I leave it as it is. I don't choose UV, I don't do anything. What decides the mapping is this node. And in between, I've made my compound where I can basically do the transformation given an X size and a Y size. And inside, if you can open it, you can open it, and you can see that I used integer division here, and I use modulo to basically distribute the images using the index across, to make them, basically I scaled the UV to this size, and then I use the integer amounts to move it 1 unit to the side, 1 unit, and then move it up, and then do the whole image. Okay, so very brief explanation. I'm going to use modulo here to do something that it's very useful for, which is check if something is divisible by something else. So I'm going to use the polygons index to check if, for example, well, say I want to do a checkerboard pattern, right? I want to have black, white, and here I want white, black, etc. So to do that, I have to check for even integer amounts. So I have the polygons index, and I want to check which ones are even and which ones are odd. So for that, I use modulo 2, and that gives me the remainder. So if the polygon index is even, the modulo will be 0. So I can check that out in here. So you can see that the white ones are the even ones. So 0, 2, 4, etc. And I can change this to another number. I can change this to 3. And now it gives me every 3 polygons. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. by checking if the remainder of that comes from modulo is equal to 0. So if it's equal to 0, it's like I had here in the juice cups. If it's equal to 0, if I have no juice left, it means that I actually filled up these 3 cups, just on the right measure. And that's basically what's being done in here. So I want to do a checkerboard pattern. And so I want to check every 2 squares. And then I want to change this by row. So in this row, I want this pattern, but on the next row, I want the inverse pattern. So in this case, I can just use the invert node here. And I inverted the pattern, but now I want to alternate it between floors. So how do I get the floor numbers? Well, I get it by using integer division. So divide, scalar, and then floor it. And so what's the amount I'm going to divide by? Well, I have this array of squares, and each row has 8 squares. So I'm going to divide this by 8. And if I plug in here, you see that, well, these are all white, but because, above 1, it just shows white to me. But this is 0, 1, 2, 3, etc. So now I will also want to check if the floor number is even or not. So I apply the same logic that I applied in here. And I have now, it gives me in black and white the floors that are even or odd. So in this case, this one is even, odd, etc. Okay, so I have basically a mask that I can apply to these guys. So I can plug them in here. And now I have my checkerboard pattern. Okay, so I want to use this pattern to basically control, say I want that in one of the color of the squares, I have the characters from the letters of the alphabet. and on the other I want to have the numbers. So let's see how can I have just a portion of this image using Modulo. Okay, so let me bring this here. Yeah, around here is okay. And let me put another Modulo in here. Okay, so let's say I just want the letters of the alphabet. I can do Modulo 26. And what this will do is the value of the integers will go from 0 up to 25, and when it jumps to 26, it resets back to 0. So it goes from A to Z, and then it repeats back to A to Z, etc. So the alphabet is done. What if I want just the numbers? Well, the numbers, the cycle size of the numbers is not 26, like the letters is just 10. So if I put here 10, I get the repetition for that size, but the letters, they don't start at 0, they start at 26. So I have to add that offset. So scalar add, and I'm going to add 26 to this. Okay, so now I just have the numbers. Well, what if I want the symbols? Well, the symbols, how many are them? 10, 4, there are 14. And I have to add an offset because they start here. So what's here? Well, I have 26 letters plus 10 numbers. That gives 36. Okay, so now I just have the characters, the symbols. So I already have, basically the ranges I wanted. I can use this this mask that I built to basically drive just the characters, the letters of the alphabet and the numbers. And now I have my checkerboard pattern with just those two ranges. Well, you notice that I have A and then C. So I'm missing A, B, C, etc. So how can I maintain the same set that I had before? Well, let's look into one aspect of it. So let me plug just the letters. If I divide the integer by 2, what will happen is that now I have the same value repeat 2 times. So because this is doing modulo, it will use the same value 2 times because it's flooring to the same value 2 times. So I can have this go to 3. I can have it repeat like 6 times. So now 6 squares have the same value, etc. In this case, I just want 2. So I'm going to leave it there, and I'm going to do the same for the numbers. And when I plug this in here, you can see that now I have A, B, C, D, E, etc. 0, 1, 2, 3. So I kept the same order they had in here. Lastly, I can just, for fun, do a swipe. So let's say that I want to use the floor numbers and use them as a swipe. So I'm going to compare this control parameter integer to the floor number. And I'm going to say if it's less than, then use whatever I've done in here. Otherwise, use the symbols, for example. So let's see how does that look like. So now I just have symbols, but if I input an integer here, I can basically have a swipe of one to the other. So this is a way to use mod logic, integer division to build your own logic. In this case, I build my own pattern. I've set up here another example, but it's a bit silly. It's a clock, and so also with you can also check it on the surface editor using the same thing and basically what I've talked in here. And so I basically did a clock. So if I come here and I put 2000 frames and I slide the timeline, you can see that I have these polygons update just like a clock, going from 0 to 24 hours. And then here at 24 hours, it resets back to 0. So it's a way to clock things, basically. So let me put this back at 100 frames, hide this object, and come here and hide this one. So last I want to talk about remapping, and for actually time remapping. And let's say that I have this object here, and it's animated like so. So it has this little bounce. And I want to loop it, and I want to copy that motion to another object, for example, this one. And so I have this item info with the bouncing box in there, and I want to copy the white channel and I'm going to just plug it in here. So if I just play through, you can see that I have that little bouncy movement in there. Now imagine that I want to loop that several times. I don't want to basically have to animate it, and I want to control, how fast or slow is each loop. I can come here to the item info, change the time mode to absolute, and click on the envelope button. And here I can basically do the same transition. So from 0 to 25, I want 1 second. So this is basically what's going on in here. And if I hit play, you see that it's the same thing. If I do post behavior repeat, it's gonna repeat the same motion over and over. But if I don't use the repeat, I can, for example, do the repetitions myself. So I can come here and I put frame in 26, and I can put, say, another repetition is going to last this long, up to frame 60. And another repetition is going to be quite fast. So 61 to, say, 80 or 75. So this last one will be quite faster. So, make these linear for a better view. And okay, so if I play this now, you can see that I have one loop, and then once a slower one, and then a faster one. Okay, so this allows me to loop, but with a different speed for each loop. Another way to do this is basically, so this is a way to control the speed of each loop. But say I want to loop this for, a big amount of seconds, and I just want to control, with some nuances, the transition, the acceleration of the loop. I can do that by, for example, let me discard this, bring here a Modulo node, plug it in here, bring in time, and sorry, not time, bring in a scalar, plug it in here, and this, I'm going to modulate the scalar to 1 unit. So at every 1 unit, it's going to reset back to 0, and that's going to make the animation loop. So if I come here and I put this 0 and turn on the envelope, if I put this at 25 and 1, I get the same thing I had before in there. So if I make repeat, I also have it repeat over and over and over again. But I can, for example, now put this in, say, frame 100, put the value 4. So for 100 frames, give me 25, give me 4 seconds. So it's matching. It's a relationship one-on-one. But I can use for example, the tension here to have a nuance on the transition. So the loops won't last the same time. So let's see that. Like, I'm going to make a preview. You can see that the first loop is really fast and the last one is really slow. So fast and gradually going slower. So this allows me to have a curved approach to many loops and not just one, and have to put a key for each repetition. So I can do many repetitions and just use a curve to modulate the transition. Now in this case, let me do the other way around, have a loop start real slow and end up real fast. So slow and then ending up faster. Okay, so this is another use of Modulo to get repetition, in this case for time remapping. Let's look into a last example, and of time remapping in a way. I'm going to call here this sphere, and this sphere is rotating. You can see that in here. And I want to do a motion blur trick. The trick is that I have the sphere at this size, and I know with motion blur it's going to look smeared. But I want the smear to look like a comet shape. So in the most forward position to look like it's at its full size, but in the most late position I want it to look real small, so like a comet. How can I do that? Well, let me first off turn on the motion blur. Let's see what we have here. Okay, so I have this amount of motion blur. I think I'm going to increase this to 150, and I think this will be a bit better. Okay, yeah, this is a bit more interesting. And so what I'm going, you'll notice that the motion blur is forward looking. So if I come here to F9, actually, let me crank this to 1000. Yeah, but you'll notice that motion blur is forward looking. So I have this blur, but if I render without motion blur, it blurs with the positions forward. So I'm going to basically have to, at this position forward, keep the scale of the object at 1, but at the current time have it at 0. So let's see how to do that. If I just, let me see how does that look. Wow, that's too much. No, it's too much. Made a circle. Now let's go with 300. I think it's fair. Okay, I think this one is good enough. And let me come here to the item motion node editor. So I'm going to use time, the time constant node, to basically get that effect. There's one particularity about the time constant node, is that when the motion blur passes are being done, the frame amount is, whatever changes, is always where I'm at in the scene. So say here I'm at frame 20, the frame amount will always be 20, but the time amount will change depending on the motion blur pass I am in. So I'm going to use that to do a remap of the object scale, so it looks like at each frame the next frames is scaling up. So let's let me just show it. So I'm going to plug time in here, and I'm going to multiply the frame. So basically I want the frame to become the same amount as time. So in here, if I check this out, I have 0.8 and I have 0.8 in both. But this 0.8 will be constant in the motion blur passes, and this 0.8 will change. And so I want to add, say, scalar add, I don't know what's the amount that I should put in here, but let's go with 0.2 for a start. And so from the current time to plus 0.2 seconds, I will have an output of 0 and 1. So if I just plug this into the scaling, it looks like the object is growing up. So that's basically the trick. Maybe this is a bit too much. Let me see, 0.1. Okay, this is a bit more interesting. So you can see that I can have that effect of the object growing up. So it works for every frame, not just that single frame, since the transition shifts with the time frame. Okay, so every frame it will render that look. And you can use this for shading as well. So for example, I can pick this up, bring into the surface editor, use a mixer, plug it on the opacity, and just have some colors to come out depending on the time. So for example, these two ugly colors. And I can also use it for luminosity. So multiply, scalar multiply, and put 5 in here. So it cranks up really well. Oh, maybe 5 is too much. Let's go with 3, and this is what it looks like. So every frame, let me change this to cyan. So at every frame, it will do that scaling according with the time. So another way to basically do some retiming. And this completes the time and repetition part. Next, let's check random. Cheers.